to eliminate output offset voltage. Okay, one of these is to apply an input offset voltage between the two terminals of differential output so as to make output 0 volts. Okay, the value of input offset voltage VIO, okay, our input offset voltage class, okay, ang pagbasa na is input output sorry, input offset voltage, okay, I for input, O for offset, and V for voltage. Required to eliminate the output offset voltage is given by V sub IO is equal to V out offset divided by our voltage gain. V out offset is our output offset voltage. Okay. Okay. For the second parameter, we have the input offset current. When when the output offset voltage of a differential amplifier is eliminated, okay, there will be a slight difference between the input currents of the non-inverting and inverting inputs of the device. This slight difference in input current is called input offset current and is caused by a beta mismatch between the transistor and the differential amplifier. Di ba class atong gi-eliminate si voltage? Okay? By applying an input offset voltage between the input terminals of the differential amplifier. Now, since atong gi-eliminate si voltage, there should be a slight difference between our current, the input currents of our input of the device. Kaya nga naman, remember in our Ohm's law, voltage is directly proportional to our input. Now, if you make a change in our voltage, there should be a proportional slight difference towards our input current. Okay, so suppose if we have um, base current 1 equal to 75 microamperes and base current 2 or IB2 which is 65 microampere, then having the formula of our input offset current, we have IB1 minus IB2. Okay, so 75 minus 65, so that would be 10 microamperes, and 10 microamperes class, mind you, it's a very small number na siya. But it's still a slight difference. Mawita siyang na difference jud. So the difference in the base current indicates how closely matched the transistors are. Okay? Duol-duol jud na sila class. There may be 1 to 2%. Okay? Slight difference, but kanang 1 to 2% class is very small na dyan na siya. If the transistors are identical, the input offset current is 0 because both base currents will be equal. But in practice, the two transistors are very different and the two base currents are not equal. Okay, those are the two parameters when our DA is mismatched. So we have next here the input bias current. The inputs to an operation amplifier requires some amount of DC biasing current for the transistors in the differential amplifier. The input bias current is defined as the average of the DC base current, meaning we have the formula here, input bias current is equal to IB1 plus IB2 divided by 2. So we're just merely getting the average. Okay? Example, we have IB1 which is 85, 85 microampere and 75 microamperes for our IB2. Okay, pareho ko calculate kaya wala ko calculate diri. So it should be 85 plus 75 divided by 2. Ilakas. So that should be pila? 80?
80 microamperes.
Okay, so that's 80. This means that when no signal is applied, the inputs of our operation amplifier will draw a DC current of 80 microampere. So kung walay signal i-apply ang atuhan duha ka input class, remember in a transistor di ba naatay V1, naatay V2, right? VB1, VB2. Kato atong maingnan nga single-ended input, katon dito ta mag-name ba. So if walay signal dito class, ang katong system or katong circuit mo-draw siya og current 80 microamperes from a DC source. Di ba naa sa tay DC source nga katong VCC, VE, right? Kuha siya dito og 80 microamperes. So the fact that the both transistors and a differential amplifier require an input biasing current leads to the following operating restriction. An operational amplifier will not work if either of its inputs is open. Lahi man na siyang walay input class o open lang siya. Kay kung maingon ta og walay input, meaning it is just connected to our ground, right? For example, naka-ground na siya. Okay? Okay? In here, this is supposed to be a signal input. Okay? But gi-ground lang siya. So, silbi, wala siya input sa ha. Right? This is not considered open class. Mayroon kag open. Mayroon kag open. Yun, ani siya. Wala gyud siyang switch nga open lang. Okay? That one is an open. Kasabot, that's an open input. Kanina siya input but directed or directly connected to our ground. So that's zero. Kani open man ni siya. When that line is open, so an op-amp will not work. Bisag usa lay open na niya class, dili jud na siya mo work ang op-amp. Since the differential amplifier will not work, the overall op-amp circuit would not work. Thus, an input bias current path must always be provided for both operational amplifier input. So if you can see on some textbook, okay, for example, this is our 1, this is our V2, okay, and naa siya bias resistor diha, naa po siya bias resistor diri. If example, walay um, input, okay, nga agkaagian diha, so naiuban nga mobutang og feedback here, nare resistor diha, nguban mobutang og feedback here, then diha na yun siya. Okay, there are lots of ways to do that. Okay, so for example, the left transistor has a beta of 90 and the right transistor has beta of 110. Find the input offset current, and input bias current, which we have to neglect our VBA. That's the condition given. What's the formula of our input offset current? Yes. For our input offset current, okay, the formula for our, let me write. So, input offset current denoted by in offset current is equal to IB1 minus IB2 Okay, that's how you solve our input offset current. Okay, so this should be 90 minus 110. Okay, pila man ni class.
Negative 20 Miss.
Okay. So that's negative 20. Oh no. Kundi hindi familiar na ko. Bo. Alright, class, lutang kayo. Okay, so for IB1 and IB2, we still don't have our IB. Sorry, sorry. Okay, we are given with beta. Okay, so for our given beta, okay, for example, we have a circuit here. Okay, we are given beta 1 and beta 2. Okay, now in looking at our given class, ang iyang gimin diha is a DC. So we will do the calculation in DC. Okay, so how do we find our IB? Remember, IC is beta IB. So in getting the beta, in getting the IB, so this should be IC over beta. Pero wala pa man tayo IC, pero na given beta. So in finding our IC, we need to find our IE, right? Ngano man miss? Because IE is approximately equal to our IC. In getting our IE, how do we solve our IE, class? Remember, we can find our IE or our tail current, okay, or IT, kung sa ubang textbook pa, that would be VEE minus VBE over RE, right? What's our VEE? That's 15 here. 15, 15 di na siya negative plus we're not looping. Okay. Minus VBE, but remember our VBE is to be neglected. Sa kana number ha, condition na siya sa number 1. RE is given 1 million ohms. So this should be 15 micro amperes. Okay, so from that, we can have our IE. We need to solve our IE1 and IE2. Okay, so given IE1 and IE2, okay, is equal, so we can have 115 microamperes divided by 2, okay, 7.5 microamperes. That's for our IE. And since IE and IC is equal, so IC1 is equal to our IC2, which is equal to our IE, which is 7.5 microampere. Now, in getting our base current, so we have IC over beta. Okay, IB1, we need to get our IB1. Our IC is 7.5 microampere divided by beta 1, which is 90. So 75, 7.5 micro divided by 90. Pila kas? So we have 83.3 nano. Class, are you still there?
Yes.
Yes.
Okay. So we already had our IB1. We need to get our IB2. Okay. IB2. So for our IB2, we have IC divided by beta 2, 7.5 microamperes divided by beta 2, 110, which is
6.82 nanoampere.
6.82 or 68.2.
68 micro.
Okay. 68.2. Right, that's 68.2. So we can find our input offset current, which is IB1, 83.3 nanoamperes minus 68.2 nanoamp. Okay, so which is equal to, what's our input offset current, class? 6.82 A8, 68.2. Yes, 83.3 minus 68.2. I think that's 1, 2, 1, 5. 15.1 nano amperes. That's our input input offset voltage. Right? Now next we need to find our input bias current. Okay? And finding our input bias current, okay, for the formula of our input bias current, so that would be input bias. So that would be IB1, IB2 divided by 2. Our IB1 is 83.3 nano plus 68.2 nano divided by 2. That's 5, 1, 5, 1, 5, 1, 75 po,
55.75.
75 point,
75 is
75.75.
oh
No?
sorry.
Okay, let's round off na lang. 75.8. Nano. So that's our input bias current. Okay. Next, number 2, Find the values of two base current given input offset current equals 20 nanoamperes and input bias current 80 nanoamperes. Okay. In finding our two base current class, napod na sila ilahang nga formula. Okay. In finding number 2, okay, for number 2, find the values of two base current. So in finding our IB1, that would be equal to um, input bias current plus input offset current divided by 2. For our IB2, that's input bias current minus input offset current divided by 2. Okay, so for IB1, okay, do we have our input bias current? That would be 80. Input offset current, which is 20 divided by 2. That's 10 plus 80, that's 90 nanoamperes. This is 80 minus 20 over 2. This would be 70 nanoamperes. Okay, so that's how you find the two base current given the formulas. For number 3, what is the output offset voltage if input bias current is 80 nano and input offset current which is 20 nano? Assume that voltage gain is 120 and RB. Base resistance is 100k ohms. Okay. Now, in finding our output offset voltage, we have the formula output offset voltage is equal to a certain voltage gain multiplied by input offset voltage. Right. So that's the formula. But we need to find the input offset voltage first. So in finding the voltage or input offset voltage, it is equal to V out, katong formula sa first, katong pagpakita na ko ani, offset divided by
A.
AV or Natay lang yung formula. Input. So we have input offset current times RB. Okay, we can make use of this formula. So V voltage input offset offset. So we have input offset current of 20 nano. Okay, balugsutan out and an RB of 110 k ohms. So this would be ilakas.
Unsay kuan sa 15 miss.
15?
Oh,
Ano siya 15?
2 times 10 raised the power of 15 miss.
Femto. Negative 15? Ano siya? 20 times 10 to the
Nag-diagnetics.
negative 9 times 100 times 10 to the negative 3. I mean times 10 to the 3.
Kuan ra day miss to milli milliamps ay to to volts ra miss. 2
2
millivolts.
volts ra.
Oh, 2 millivolts.
2 volts, 2 millivolts. So much siya?
MV miss. MV day.
Okay. Okay, so we already have our input offset voltage. So we can then find our V output, okay, or output offset voltage. So since our what it goes AV, our voltage gain is given, so therefore this one here is 120 times our 2 millivolts. That would be 240. Sakto ba millivolts? 120.
0.24 miss.
Kuan man na siya. 120 times 2 times 10 to the negative 3.
0.24
Ito ba?
miss.
0.24?
Oh,
Oh, okay. 240 milli lagi. 0.24 volts and it's 240 milli.
yes miss.
Okay. So we already have our 1 and 2. Now for number 3, oh, okay. What is number 3 pala? So 1, 2, 3 are done. Okay. Do you have questions so far with the formulas and all? Hello.
So far, none, Thomas.
Okay. Okay, going back here. Okay. So we're down with the AC analysis of differential amplifier. So for AC equivalent circuit, we can easily find the AC equivalent circuit of differential with all DC sources. Ano man eh? Wait, also.
Miss, naka-mute ka, miss.
Ah, okay na kaya. Nag-drawing pa man ko. Okay. So if you're given a certain circuit, okay, the same lang ang mga circuit before class. Okay, we are given RC, we have output, we have Q1, Q2 transistor, we have our IE or our tail current, and we have our VEE. Now, if we're going to do analysis in AC, okay, that's the equivalent circuit. Remember, in reducing the voltage source, you can just you can just short it, right? Or you can um, connect it to ground, okay? And ang ato ang emitter resistor class is it is broken down into two. Gitang sa tag sa si Q1 and Q2 and it is denoted by RE prime. Okay, given that class, RE prime, RE prime, R sub E prime is is just 25 millivolts divided by IE. That's the standard formula. And our RE is our AC emitter resistance. Okay? Di ba ang atong emitter resistance class is just RE kung mag-DC ta. Now, if we're involving AC analysis, so that's RE prime. Okay? That's RE prime. Now, given our IE, okay, we need to find our IE gas. In finding our IE, we can have this one, which is our input divided by twice of our R. Okay, kaya nga naman, gikan man ni siya diri, okay, na siya input here, and that's voltage input, na moagi RA diri usa, na moagi RA diri usa, and they have IE nga usa. So, Vin minus IE 2RE equal to 0. And manipulating the equation, we can have the formula for our IE, AC analysis. That's the formula. And that IE class is called AC. Pangalan dyan na ninyo yung AC. AC emitter current. Okay, and same with our DC. In AC analysis, our IE is equal to our IC. Okay, that's our RE prime and IE. Another formula regarding with AC analysis is the output voltage. Output voltage or V out, which is equals to our Ohm's law ICRC, or it's just equal to our Vn to oops Vn2 Re prime Rc. 'Di ba remember class, this is our IE which is just equal to our IC. So ang IC in terms na to o voltage and resistance. Okay, nya gikopira nato si RC, okay? Voltage gain, I mean output voltage, that's the formula. Okay? Kung dili given si IC, given si input voltage o si AC emitter resistance, then you can find V output in terms of that. If output is still not fine, pero given si input o si RA lang, you can just directly substitute that one, okay, to find our V output. So, next is our voltage gain, AV. In finding our voltage gain class, remember in finding a gain is output over input. Okay, so since this is a voltage, so voltage output divided by voltage input. Now remember, atong voltage output is, what's our voltage output? This one, right? So that's V in 2 RE prime RC, okay, divided by our V input, which is V input ra. Nya inigbali ni mo na class, si V input is makancel. So basically, our AV voltage gain is just equal to RC divided by 2 RE. Right? That's the formula. Okay. Another is we have a differential voltage gain, or the ADM. ADM. Our ADM, or differential mode voltage gain, is just equal to our AV. They are both gain in AC analysis. Okay. Let's try some example. So we have here, what is V output when we have input of 2 millivolts and another input of negative 2 millivolts. That's A and B. So, unsa itong ipahita? Si V out. Okay? Si V out, ang formula ni V out, what's the formula of our V out? That's, there are, right now, I can think of two. Okay, so the first one would be the one that I just gave, the, the, um, the V in divided by 2RE, okay, RC, or the formula ADM equals V out over V in. So, makuha na to si V in, ana. Okay? Ako'y copy B. Okay. V out. So, formula of our V out, given si V in, okay? If Vn is given, so we can basically use V output over V input. Okay, and our V out class can be manipulated from the formula. Let me write V out over V in, right? If we want to have our V out, so that's V in times ADM, right? Now, given V in is given 2 millivolts, we don't have our differential mode voltage gain. In finding our ADM, okay, remember that's RC over 2 RE prime. In getting our RE prime, oops, in getting our RE prime, that's 25 millivolts over IE. In getting our IE, we have the formula V in to RE. Or, okay, or if you are given a circuit, okay, kung makakuha ta og circuit class, then we can make use of that circuit. For example, we have here kopyahon na lang ko ni. Oops. Okay, so if you were given that one, okay, and so ang pagkuha sa ato ang IE, that's BVN over 2RE. Okay, ang pagkuha sa atong IE, okay, ang pagkuha sa atong IE is through DC analysis. When getting the IE class, which is basically equal to our IC, so let's do IE or tail current, VEE minus VBE over RE. Excuse me. That's 15 minus um for example, wala gineglect si kuan VBE. Since wala man gineglect si VBE, so we can have this one divided by 1 mega. So 15 minus 0.7, that's 14.3. Palihog ko kung sakto.
Sakto ra, miss.
Sakto na. Okay. 14.3 micro. That's our IE. And then we need to have the IE nga ginagmay. IE nga ginagmay divided of 2. So this should be so for that one, 14.3 divided by 2. So that's 7.15 sa IE 1 and 2.
Yes, miss.
If I'm right. Okay, 7.15 micro. That's for our IE1 and IE2. Now we can have our RE already. Okay, so since RE is 25 millivolts, IE. So that's 25 millivolts. IE is 7.15 micro. Three pilakas. 3.5, 3.5, 3.5 kilo.
3.5 miss.
Okay, so since we have our RE, then we can find our ADM. Our ADM is RC over 2 RE prime. So our RC is 1M, twice of our RE, 3.5 K. So that's pila times 2 divided by 143 kung sakto ko.
Yes,
1
miss.
4. Yes, miss. 0.80.
43, that's unitless because that's a gain. Since we have our ADM, unsa gipangita? V out. So V out is 2 milli times 143. So that's 286 milli kung ako masayop.
Yes, miss.
Yes, miss.
AB negative 2 millivolts, 143. That's negative 286 millivolts. Okay, so we already have our number one. Now for number two, it is for the input impedance. Now for input impedance class, okay, in here, okay, so for input impedance, if we are given, if we are given an IE, which is Vn over 2 Re prime. Okay, now Vn over 2 Re prime plus, okay, is just equal to our IC, right? IC, because IE is equal to our, almost equal to our IC. Now remember, in finding our IC, that's beta IB. So basically, our Vn2Re is just equal to our beta IB. Gi-equate ra na silang duha. So now, since Vn over IB, okay, is equal to our 2 beta Re, gimanipulate na na siya class. Okay, now given this one, that's our impedance. Diba, remember class, voltage divided by current is resistance. But since this is on AC analysis, so that's impedance Z. So in here, Vn over Ib is supposed to be a resistance in DC, so that's AC, that's impedance for AC. And impedance is just equal to our 2 beta Re. Okay, now this 2 beta Re class is now our impedance input. Okay, now our Z input is just equal to this one. So ito ato orang kopya si 2 beta Re. Now in solving for number 2, Sayop man ni. V out is um V in ADM, V in ADM. Okay, kung mag-multiply ta, that's ADM. So that's 1, 2 milli divided by 143. I-divide na class. Sorry, nalipat ko. Um, Ay, kalutang gud na ako. Sakto naman to, eh. Di ba? Pasensya kay class. Why tugin yung maestro?
Tara, miss. Pauwi
Sorry.
sa miss.
Batog sa tamis.
Mo, kaya nakatuog na mo. Okay, so for example here, for number 2, okay, I think find the input impedance and the differential voltage gain or the ADM. For the input impedance, diba, we have the formula for this one, okay, 2BRE, and we need to find our RE prime. Our RE prime has a formula of 25 millivolts divided by IE. In finding our IE, we need to find our tail current, okay, and divide it by 2. Now, given a DC circuit, doing DC analysis, so that's VEE, ako na lang dito on. IE is VEE, which is 12 minus 0.7 all over 100K, which is equal to 113 microamperes, and divided by 2, 113 microamps divided by 2, that's 56.5 microamperes. Okay. Now, given our IE1 and IE2 is 56.5, therefore our IC is also the same, but we are looking for our RE prime. So that's 25 millivolts divided by IE, which is 56.5 microamperes. So this is 442 ohms. Okay. Since we have our RE prime or our AC emitter resistance, we can then find our input impedance. So input impedance ZI is twice of our beta RE. So twice of our beta, which is 220, our RE, which is 442, we can have 194 kilo ohms. So that's our input impedance. Now we need to find the ADM of the following circuit. Now for our ADM, we have options to solve it, which is V output over V input, which is also RC over 2 RE prime. Okay, hopefully ma-remember. So that's RC, which is 120K, twice of our RE, which is 442. So this is 136. Okay, ako na siyang i-calculate para dali lang kanina. Okay, so for the last topic for prelim coverage, sa man? Oh, okay. So the last topic class would be the common mode voltage gain or our ACM in AC analysis. The common mode signals are equal in amplitude and have the same phase. Ideally, there is no AC output voltage with a common mode input signal. It is because a differential amplifier is designated to respond to the difference between two input signal. There should not be any voltage output class, okay? Because our amplifier is iyaharang i sana iharong basahon ang katuang limpyo nga input signal. Okay? If there is no difference between the input, our output there is zero. In practice, the two halves of the differential amplifier are never completely balanced, and there is a very small AC output voltage for the common mode signal. Now, given ganina class for our AC for the ADM differential mode voltage gain, di ba? If we put a voltmeter towards our output, bisag wala siya input signal gibutang na siya output signal nga nabasa. There is an imbalance. The same for our common mode voltage gain, naaman siya gamay nga DM output, differential mode output, there should be a very small common mode output. Okay, assuming identical transistor, the two emitter currents will be equal and produce the same voltage across emitter resistor. Therefore, there is no current through the wire between the emitters. Ayan, gimina na is this one. So for ACM, if we have a circuit, By the way, class, puwede ko mangutana, kinsay officer ninyo diri? Ang inyong officer ba presidente ra kautob or class mayor ra? How about kanang tanan na? For example, nay Muse, nay Prince, naba mo na?
Naa, ma'am.
Kinsa inyong Muse?
Si Den sa Prince, miss.
Uy, buot-buot.
Kinsa inyong Muse?
Wala, bitaw, ma'am.
Si
Kasi
Den sa miss.
Wala mo ga-election din.
wala ra, miss.
Yung ano, Miss
Oo.
Mayor.
Kay nangita man og representative for intramurals.
Pwede ra ikay mamili, miss.
Si Rex na lang.
Oo, sakto sa.
Yay!
Ivan, miss.
Aldrin pag miss.
Oh, wait.
Hindi ko pasara na, miss, kay mubo ko.
Kung nag-iingon ni Ma'am Cheryl, ano siya nga, kanang estudyante nga taas-taas. Taas man ko mga estudyante, miss. Na siya basta kanang makapasa lang height. Kisa may pambato class. Tingog ko na mo, be.
Ronilo, miss.
Si JK, miss.
Class pagtarong kaya mag-send ko og list sa names ni Ma'am Kuan, Ma'am Cheryl. Si Rex,
Ay,
si
oo, man siya. Si Brian lang, miss.
Mark Bryan.
ah, si Mark,
Ay, lano,
siya
noon
pa,
sa
si
day, miss.
Lauren,
Ayaw, ma'am, ayaw.
James Reid na lang, ma'am.
Mario, ma'am.
si Kuan, si Lawrence. As man si Lawrence, di ba?
Mario, ma'am, bag-og tupe.
Ay, bagong tupi kay di pa sudlon sa eskwelahan. Kung di magpatupi. Sige lang class, ako lang maghatag og list ni Ma'am Che kay hinoon nakakita naman si Ma'am Che sa inyo. So, siya ray, kuan, siya ray mohusga. Okay. So, for this one, okay, ang equivalent um, circuit analysis is if we have an RC here, and circuit Q1, a transistor Q1, Q2, and if we have RE, negative 12 volts, 200K, 100K, and a 12 volts here. Tuwingon na lang nako tanan. Okay, so for this one, if we have a certain circuit here, okay, the equivalent circuit for our common mode is this one here. So if you have an RC, okay, and we have a Q1, Q2 transistor here, okay, ang iya di akas is iyang short because they have common mode signal, okay, but since ang giingon niya diri is in here, assuming identical transistor, the two emitter currents will be equal and produce the same voltage across the emitter. Therefore, there will be no current through the wire between the emitters. So basically, class, mawa ra ni siya. Kani akong gidrawing nga wire between the emitters. This one here. Since ato siya gi-assume nga identical silang duha. Okay, so the emitter flowing from here to here and the emitter flowing from here to here is just basically equal. So dili na siya wala mawala ang sense sa ato ang wire. Okay, now for an example, we have here a circuit. Okay, Mhm. We need to find what's the form calculate ACM given RC and RE and a common mode voltage gain with a CMRR in dB. Okay? For number 2, muna siyang katong given nga circuit. So let's start with number 2. So the formula for ACM is V out divided by V in for the CM, which is equivalent to our RC divided by RE plus 2RE. Ang 2RE class is in here. We have RE here, right? And 2RE here. Okay. Now, given the 2RE and the 2RE class, giusaran na siya og 2RE, gimultiplied by a single RE for an AC. Okay? Since we are doing the AC analysis from our DC ato siyang butang to AC. So, if we have here ACM, V output divided by V input in common mode is just equal to our RC. Okay, RE prime plus twice of our RE. RE jud nga RE. Okay, now given that one, okay, so CMRR, what? Okay. Now, given that our RE prime and AC analysis is very, very small, okay, very, very small na siya class because si common mode signal is very small naman lang na daan, di ba? Because it is a common mode signal which is a noise, pick up noises, okay, from our line. Now, since RE prime is very, very small, so very, maneglect ra nato na siya, which is very equal to RC over 2RE. Kopya. For our ADM class, remember our ADM is, di ba si ADM is RC twice of RE prime. Okay, gamay siyang R. For CM, dako siyang R. Okay, do not be confused. The same na silang nawong, but lahi ang um, R ing ayang gimin. So for number 2, let's start for number 2 first. Okay, naatay circuit. So for number 2, if we have here, okay, so if we have here a common voltage gain nga unknown, so si common voltage gain na ay ACM. Formula nga RC2RE, right? Pwede ra ba din nato madiretso? Pwede. Kaya wala naman tayo RC. Kasunod ra mo class, we have twice of our RE which is 200K. So 100 times 400. So that's 1/4, which is 0.25 unit less. Okay. Now, since we have our ACM already, we need to find the CMRR in dB. Now, for the CMRR in dB, so for CMRR in dB class, the formula would be ADM divided by ACM. So we already have our ACM. We don't have our ADM. Remember, our ADM is RC twice of RE nga gamay. Okay, now we need to find our RE nga kamay, AC emitter resistance. So finding the RE prime is 25 millivolts divided by IE. But we don't have IE yet, so let's solve. So IE is 12 minus zero point 0.7 divided by RE, which is 200K. That's 11.3 divided by 200K. 0.0565 milliamperes or 56.5 micro. Okay, it's the same. We divide it by 2. So 0. Ato na lang yung 56B. 56.5 microamperes divided by 2. So that would be 28.3 microamperes. We have our IE already. Now, to solve for the ADM, that's RC. RC is 100K divided by twice of our RE, which is 883.4 ohms. Okay, twice 883.4, which is 56.6. Okay, now that 56.6, we can substitute it here. Okay, so CMRR in dB, ireso na lang ko ni, is just equal to 56.6 divided by ACM, which is 0.25. Okay, 20 log 56.6 divided by 0.25. Ina, kuha ra, plus. Now,
Yes,
in finding
miss.
ACM for number 1, napang data number 1, no? Saan naman ang ACM? ACM, that's RC, dako nga R. Okay, so that would be RC is 150K, twice of our 143K. So ACM is, pag mo kasolve, is it 0.524?
Yes, miss. Wala na siya unit, miss.
Yes, again is unitless.
Serious. Thank you.
Okay, do you have question? Tas nara may question, that's the last topic for your prelim. Andam na mo for next week, taas mo time to study. So I'll be expecting some good scores from you, class?
Miss, expectations is the root of all disappointments.
Sakto-sakto.
But it, sakto, kung dili ta magkaon, it will not be a disappointment if we study. 'Di ba?
Sakto, miss.
Di manawag pud tagkuan ba? Tawagon po na to atong guardian angel. Guardian angel, may di ko malimot.
Focus ganay, miss.
Okay? I-train na iyong guardian angel ka sa inyong memorization skills, analysis, okay? Para maanad na ta, puhon. Di na mo maglisod. Okay? Kay, third year na mo. So if you don't have any questions, class, we can leave the room now. Okay? Have a happy lunch, everyone.
Happy
Happy Teacher's
Teacher's
Day, ma'am.
Day, Miss.
Yeah, Miss. Happy Teacher's Day, Miss.
Happy Teacher's Day, Miss.
Papasa
Oh,
niya
good
miya ni
night.
ma'am
Day,
kani ma'am
Miss.
ang notes ma'am ba?
Oo, ihatag na ako ang notes. Thank
Sige
you,
ma'am.
Thank you,
class.
ma'am.
Sige, bye.
Years, Miss.
Buyers.